didn't notice, yesterday was a bit of a total disaster for all sorts of reasons. And just to add to the insult to injury, the video disappeared on me as well. So there is no video from yesterday. But since we're covering this topic, I don't think that's going to be a big thing. And most of what we could do, at least while I was doing it, was all about generating the limits of integration. So we're going to return to the questions and do the full thing. So essentially what the divergence theorem allows you to do is to find this special version of a surface integral called the flux. And this double integral, the surface integral, can be calculated by getting a triple integral of the divergence of the vector field F dv. dv could and very often is dy, dx, dz, right? It'll have three variables in it. But it could be spherical, it could be polar as well. Depends on what the region looks like, what is the best way to represent it. The E that we're talking about here is the 3D solid formed by the surface S. So can you imagine that the surface S, well, let's take a simple, can you imagine the surface S was actually the surface of a sphere, right, the skin? Then E is the entire sphere, right? X, Y, Z inside the sphere, right? If the surface was actually a box, right? All six sides of a box, which is quite a common one to do, right? If you thought of that as the surface, then E would be the would be the X, Y, and Z would come from the dimensions of the box. Right? So it's pretty common that you get straight-sided objects. So this is a condensed version of our first question, number 2. There is your vector field. S is the surface described by this. Now that's the easiest question in the world, because isn't that the limits of integration handed to you on a plate? The only thing is that it's not 0 to 1, 0 to 4, 0 to 10. They're just calling it A, B, and C. But think of A, B, and C as constants, right? And treat them exactly as you would do. So we're being asked to find this surface integral called the flux. And it's going to be the triple integral of E, the divergence of the vector field dv. And I'm going to calculate separately that fella. So you find the partial derivative with respect to P, partial derivative of that with Y, and the partial derivative of that with R. And up here, there's your P, this guy's your Q, and this guy's your R. I'm not going to do this again. I'm going to jump right into the answers the next time. So if you differentiate this with respect to X, you get that. If you differentiate this with respect to Y, you get that. And if you differentiate this with respect to Z, you get and that guy and that guy. What about this one? Oh, that's a bit of an annoyance, but never mind. We get 2xy plus 4xyz. How does that look? Because I think I made a mistake. And I did, because that's got a z in it. So that's got a z in it. So we actually get 6xyz. Much nicer. What we had before would have worked, but that's nicer, so we'll use it. Right, so I've now got all the pieces that I need. I've got the divergence, and I should be able to put them together. So this surface integral is going to be the integral from x equals 0 to x equals a, y equals 0 to y equals b, z equals 0 to z equals c of the divergence. And this one lends itself to doing a z, a y, and an x. A, B, and C are constants, right? They're just numbers. Does this triple integral separate? So I'm going to give the 6 to the x. I'm just going to give a single y to the y's. And I'm going to give it a single z to the z's. We're comfortable about that split? And technically, couldn't have given the 6 to any one of the 3 as long as I only gave it to one of them. So that guy gets you 3x squared evaluated at 0 to a, and that gets you 3a squared. This guy gets you 1/2 y squared evaluated from 0 to b, and that guy gets you 1/2 b squared. And this one gets you 1/2 z squared evaluated from 0 to c, and that guy gets you 1/2 c squared. So it looks like the answer is 3/4 a squared b squared c squared. So the flux, which is basically the total of what's going in compared to what's going out. I think that's how you described it to me. Well, is that what a flux is? On the surface, things are going in and things are going out, and the flux is kind of the sum of those two different components. So evidently that's what the flux there is, and I'm on a roll. It's the right answer. We're comfortable about this? This is just another way to find a surface integral called a flux. So it's a special version. The next one is same basic issue, find that guy. In this case, the vector field is going to be x squared, y squared, 2xy, z. And we're told that it's a tetrahedron. Wow. Which is basically one of those shapes, triangular pyramid. And we are told that
it is the ultimate plastic caltrop is what it is.
They are like worse than a Lego.
They are? Oh, standing on them is not a good idea.
Yeah, it's called a four-sided die. They're horrifying to step on.
Right. They do a version of that where they put spikes on an object, and they basically are the triangle with one sticking up. The advantage of these spikes is no matter how you roll them, there's always at least one of them pointing straight up, so they're a great way of bursting tires. No,
the Romans loved them for dealing with cavalry too.
Yeah, I mean, horses standing on them. People, you know, especially if the enemy was not wearing shoes, which might seem unreasonable.
Sorry,
but yeah,
tangent is not, and that's
correct.
my fault. I'm sorry.
No, it's cool. I drift as well. It's fun. So we're told these three guys, which then gets placed with this guy. And we have to figure out how to get the limits of x, y, and z by knowing it's this shape. Basically, if you take a plane and you cut it, do you know they could have just said the first octant and it would have been the same thing, right? Your guy's going to look something like that, right? So what we need to do here is we need to find these two in particular, right? The z is easy. The z is going to go from 0 to rearrange this. And this is going to do -x, -5y. So there's my limits of z. The x's and the y's are the tricky part. So we need to find out where this fella crosses the x-axis. It can't be 0. Oh God, no. My apologies. There. Right. So where does this cross the x-axis? It crosses the x-axis, and put my 10 in while we're at it, at 10. And it crosses the y-axis at 2. And z is 10, take away x, take away all that other stuff. So I'm taking this guy, reorientating it, and I'm going to put 10 here. I'm going to put 2 here. I'm going to join it. And that guy there is going to be how we're going to describe the x's and the y's, right? I've done enough of these triangle ones that they become kind of second nature, don't you do that guy? And so my x's are going to go from 0 to 10. We're comfortable with that? And my y's are going to go from 0, because they told me, right? To whatever the equation of that line is. That line has a slope of -1/5, and it passes through 2. So we have now set up the limits of integration for the solid. Go from 0 to this guy, 0 to 10, and 0 to this guy. I also need to figure out what that's equal to. So it's going to be the partial derivative of this guy with respect to x, the partial derivative of this guy with respect to y, and the partial derivative of 2xyz, this guy, with respect to z. And so I get what? 2x plus 2y plus 2xy. That's fine. Right, so I now have all the pieces. So this surface integral, the flux, is going to be the integral from x equals 0 to x equals 10, then from y equals 0 to y equals -1/5 x add 2, and then from z equals 0 to z equals 10 take away x, take away 5y of the divergence, which is this guy, and do z, then y, and then x. Now, I had 3 limits of integration here, yet this is the only order that makes sense. How do I know that? How do I know which order to put them in? How do you?
Because of the number of variables.
Okay, so the one that's got the most would be that one. So he goes first, right? It has x's and y's in it. And then I'm assuming you mean that one goes next because it does have some variables in it. And doesn't the one with the numbers always go last? Okay. Most variables, not so many, none at all. Now this entire horrible mess is a triple integral. And it's ugly, messy, maybe that's a better word, but isn't it doable? Right. Integrate with respect to z, right here. Plug in z as this guy, plug in 0. You will get a horrible expression with x's and y's in it. You will then differentiate it with, integrate it with respect to y, plug in this guy, plug in that guy, and you will be left with a even more horrible probably looking expression, but only with x's in it. And then you integrate with x and you're done. Not separable. The minute you see these things, you can't make your life easy and separate them out. And are we good with that question? I don't want to spend, whatever.
I get we can't separate the variables, but we can't, find a value for what they'll be. I mean, I see that we can't. It's just very frustrating.
Yeah, it would be nice if there was a quicker way of doing the calculation. There isn't, not that I know of at least. Next fella is plenty of time. Next guy is number 4. Oh, they ask you to, I was trying to figure out what it was asking. They're asking us here to compute the flux. So they don't even write this down. They just call it the flux. So they want us to get that. And the vector function, I'm going to have to do it down here. It's really big. The vector function is sine x cos squared y. The middle one is sine cubed cosine 4. And the z component is sine 5. Oh, I should pay more attention. That's a y, and this is a z. My scanning is not great. And then the last one is that guy with a cosine 6x in it. That is pretty ugly. I wouldn't want to do that unless I had to. And what does our surface look like, or at least a 3D region generated by our surface? You've got this guy. You've got this guy. And you've got this guy. And it's a cube. Okay. So I'm assuming that it's a cube, that you start with zeros. So there is our region. It's a strange way of saying it. Do you know, I would have said a cube centered at the origin with sides pi upon 2. But I mean, it's a cube, so I'll live with that. So our guy is going to be the integral from no particular reason, since they are all numbers. I'm just going to do x. I'm going to do y. Then I'm going to do z. If you differentiate this guy with respect to x, you're going to get a cosine x cosine squared y. Plus, if you differentiate this guy, let's double check. Yikes. Ugly. If you differentiate this guy, you are going to get 3 sine squared y cosine y, and you're still going to have the cos 4z. And if you do this one with respect to z, you're going to have 5, that guy to the 4, times a cosine of z, and you're going to finish with that little squiggle up there as a 6. Oh, God in Himmel. Does this turn into anything? Well, I know what the answer is because I can see the answer, but what the heck does this turn into? I'll just put the triple integrals there and assume that these numbers.
That little bit squished up to the cosine y? I can't read it. It is too squished.
Okay, it is very squished. I'll write it again then with a little bit more room. We have a cosine squared. And then we have a 3 sine squared y, cosine to the 4 z. Even although that, I still don't have enough room. So the last one is 5 sine to the 4z, cosine to the 6x. And then you would just do a dz, dy, dx. And I'm going to tell you that the answer is 19/64 pi squared. there is no way in the world that thing is doable in a minute. If you just take each one, which you would have to do, right? And that one's okay with respect to Z, right? You just stick a Z on it. That one in the middle, right? See that guy there with the cosine 4th power of Z? That stuff at the start doesn't matter, but the cosine to the 4th power of Z, you want to trust me, that is a Calc 2 question that's going to take you 20 minutes. And this guy here at the end, that cosine, that sine to the 4 guy, he's also going to take you 20 minutes. So now that I've seen what this question looks like, and I'm telling you the answer, will you just remember the answer and type it in and call it good? Because there's no way in the world I would ever ask you to do something as horrendous. Nobody normally would do that. Do you know if somebody gave me that? Wouldn't I just go to Mathematica and type it in and find out what the answer is from them? Because I don't want to spend an hour doing it. So, I mean, it's kind of cheating, but
What's
19th
Mathematica?
say again?
What is Mathematica?
Mathematica is a piece of software that is designed to help mathematicians do computations. And it's also clever in the sense that it doesn't just work numerically, it can also be tells you an answer algebraically. It's a cool piece of software. But you don't need to know it because you're not going to use it. Certainly you're not going to use it in the final exam, because if I don't see working, that ain't, there is no points. But I would never give you this question in the final exam. That's just not right. Okay. I didn't, you know, when you pick the question, all you see is the question and then they tell me what the answer is. And it looked like it was going to just be one of those, those horrible messes where everything kills each other off and it's nice. That's what I assumed it was going to do. And I was totally wrong. We have done question 5 before, but I just want to remind you of it because it did kind of get lost in the hassle of what happened yesterday. Here is our vector function, which is that guy, that guy, that guy. And the region is called a fat sphere and was something like, they changed them a little bit each time, but it was that guy. And trying to set up the limits of integration of this would be absolutely horrendous. But the good news is this ends up being 0. So let's see why. Just to remind you, that's P, that's Q, and this is a right, basically doing yesterday. If you differentiate this with respect to x, you get 2x sine of y. If you differentiate this with respect to y, you get negative x sine y. And if you differentiate this with respect to z, you get negative x sine of y. Do you see everybody ends up being 0? And when you do your surface integral, the flux, aren't you going to be doing the triple integral over some region E of 0? And integrals of 0 are 0, so the answer is just 0. So this vector field, if you looked at this region, it tends to be spherical, but more kind of squashed, right? It's symmetric in the X, Y, and Z, but it's kind of, the Earth is much more like that. We think of the Earth as a sphere, but actually the Earth is not the same north to south as it is east to west. Look it up, there's a difference, right? So that's what that shape looks like. But what this is saying is that if you look at all the points in the surface and you looked at what was going in and what was going out numerically, it's totally balanced. Wouldn't that be I'm trying to think of what an equilibrium surface, right? It would be a surface where nothing is getting lost and nothing is being gained. Right? It'd be right. The stuff leaving the sphere is exactly balanced by the stuff coming into the sphere. Any questions so far? Are we good when you see the whole process start to finish? Okay. Just moving through them all one at a time. I'm going to do a version of question 6. This guy is e to the x sine y, and the middle term is e to the x cos y, and the last term is y z squared. And we are doing x equals 0 to x equals 4 because they tell me y equals 0 to y equals 3, and we're doing z equals 0 to z equals 2. So basically, can you imagine a 3-dimensional box, right? 6 sides to it. This is the vector field that's passing through that box, or the box is passing through the vector field, whichever way you want to think of it. So the divergence is the derivative of this with respect to x plus the derivative of this with respect to y plus the derivative of this guy, make sure it's the right guy, with respect to z. And we get that guy. So the flux is the integral from 0 to 4 for x's, from 0 to 3 for the y's, and 0 to 2 for the z's. The divergence is that guy. And we're doing a z, we're doing a y, we're doing an x. Would you agree this separates? And we can separate them because the limits of integration are all numbers. So I'm going to do 0 to 4, and I'm going to give that the number 2 because I want to. And 0 to 3 for the y, and 0 to 2 for the z. Okay, that guy gets you what? 2x evaluated at 0 and 4, so that gets you 8. This guy gets you 1/2 y squared evaluated at 0 and at 3, so that gets me 9/2. And this last one gets me 1/2 z squared. That guy, 2 2s 4, 4 2, that gets me 2, and the answer is 72. And it's right, it is 72. Pretty straightforward. All of these with that one there, aren't all of these boxes of various kinds, right? The solid shape and fixed values with the, one tetrahedron, forgot about that one, with one tetrahedron. Okay. So let's do another tetrahedron one. Let's tell you, this is my own. It's in the first octant, which is pretty common. And it's 2x, take away 4y, and we better shoot that's right, plus 4y minus z equals 8. And this fella is xy, xz, xyz. So we're being asked to find the flux of this solid shape. The surface is built from this solid shape in the first octant meeting up with that plane. So if you imagine what it might look like, it crosses the x-axis at 4. It crosses the y-axis at 2. And it crosses the z-axis down here at -8. And I'm going to have to make that a plus because I said the first octant, didn't I? So it's up there now. So I can tell that z is going to go from 0. And if I rearrange this guy, it becomes 8, take away 2x, take away 4y. So that's the range of the z's. If I then use these 2 points and rearrange them, I should be able to find out what we have. We have an x at 4 and a y at 2. So we're basically going to do our classic triangle. In this case, the triangle is going to go from 0 to 4 because it's in the first octant. And the y is going to go from 0 to wherever there is. And that is -1/2 x plus 2. That's very similar to the last tetrahedron one, right? Just given to you in a slightly different way. So our fella, our surface integral, is going to be equal to x go, well, you tell me. Based on these limits of integration, which terms should go on this, the last integral? Here are our limits of integration.
X 0 to 4.
You all happy with that? Numbers should go last. Right, now we've got a middle integral limit of integration and we've got the first one, right? The one you would do first. So let's pick on this one. Which one do you do first? The y's or the z's?
Z.
Great. Isn't it the same reason that Sally gave earlier, that the one with more, well, have I got this in the right place? The ones with the most variables in it, in this case, that one, and then the y goes in the middle. In this case, I need to find the divergence, don't I? And should be able to do that right now. If you differentiate that with respect to x, if you differentiate that with respect to y, you get nothing. And this with respect to z, you get that. So you are going to be doing dz, dy, dx. And it's ugly, but it's not hard, right? It's just messy. Integrate with respect to z, plug in numbers, then move over here, integrate with respect to y, and then put in these terms, then move over here and integrate with respect to x, and you get whatever answer you happen to get. Are we good? I know I told you the joke about the engineers going for the job. Did I tell you that one? There was this, an engineer.
It was the OC engineer one? Yeah, I think you did.
Right. So
Where the plane won't get off the ground or it won't
Oh,
start.
I told you the one about the plane not getting off the ground. Did I tell you the one about the engineer going for a job?
Or you also told a bridge one, I think, but I don't remember a job one.
Okay. Well, there was a mathematician, an engineer, and a lawyer go for a job with this big company. And mathematician goes in first, and the guy is on his own, one guy interview, and he says to him, What's 1 plus 1? Mathematician said it's 2. And the guy says, are you sure? He says, it's 2. It's always been 2. It's 2. That was the end of the interview. A little bit puzzled, but he left. So the engineer goes in, gets the same question, and says to him, what's 1 plus 1? And engineers aren't too bright, so they had to think a little while, and eventually said it's 2. So the interviewer says, are you sure? And so he thought a little while longer, and he says, well, just to be really certain, it's 2 plus or minus 1. And that was the interview over. And the lawyer goes in, and he gets the same question. The guy says to him, what's 1 plus 1? And the lawyer doesn't say a thing. He just gets up, and he goes and he closes the office door. And he goes over to the windows, and he closes all the curtains. And he goes over to the interviewer, and he goes really close to his ear, and he whispers, what do you want it to be equal to?
That's pretty funny.
Oh, come on, Tessa, is that a good joke?
Better than what I can tell.
Okay. I'm just trying to give my brain a breather because I know how horrible the next question's going to be. So I want to be in a nice, happy frame of mind.
Did you hear about the
Oh,
parallel
God, no.
lines?
They couldn't get together.
Yeah, it's a
Have
shame
so much
because
in
they have so
common,
much
but
in
the thing
common.
they'll never meet.
Okay. Did I tell that this is my last joke? This one has come into my head, and when jokes come into my head, I just have to tell them or whatever. Right. Did I tell you the joke about the Scotsman, the Englishman, and the American went for an interview with the CIA?
Yeah, you have.
Okay, then I don't need to tell you that because blah, 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 punchline, people did. Right, let's get started then. The horrible one, at least in my mind, is coming up right now. So this is question 8, or at least a version of it. The vector function, vector field, is x cubed y negative x squared y squared negative x squared yz. And the surface that's going to generate my solid is bounded by a thing called a I can't even say the word, hyperboloid. And it has the it has the equation that guy equals 1, and it's being cut by z equals 1. No, it isn't. It's being cut by z equals -3 and z equals 3. So the hard part of this is trying to generate the limits of integration based on what you can see here, right? And I've just realized, because now I've looked at the answer, that my life is so much easier than I thought it was going to be. And I think it was Connor who went and said, the moral of the story is always find the divergence first to see if you actually need to do anything. And I broke that rule by not looking at what the divergence is. So let's do it. The divergence of f is differentiate this guy with respect to x plus differentiate this guy with respect to y plus differentiate this guy with respect to z. Do you see a nice answer? Do I even care what the limits of integration of this are now? So instead of being a really horrible question, it went the exact opposite. Isn't it a really easy question? So this fella is 0. But since I am wanting to fight my way through that because I had a mindset that I wanted to do the limits of this, can we pretend that this function wasn't zero, right? In other words, we'd have to do it, right? So a different question where the divergence wasn't zero. I know what the Z values are, right? Would you agree you get them for free?
This one I think would lend itself nicely to cylindrical coordinates with a radius of square root of 10.
It does exactly that, Sally. You're right on the ball. So let's show you what's happening. I have this guy, right? If you plug Z equals 3 in here, right? Z equals 3 in here, you will get x squared minus y squared, take away 9 equals 1. And that, no, not negative plus, sorry. X squared plus y squared equals 10. And that's what you get when you plug in negative 3. Can you trust me that if you plug in Z equals 3, you still get the same guy? So far, so good. Now, is it that a circle of radius root 10? So I would do r equals 0 to square root of 10. It's the entire circle. So I would do 0 to 2 pi. And when I do my triple integral, I'll do the z's at the end, right? So z's going to go negative 3 to z equals 3, right? Whatever my thing is, right? And I would do an r, dr, d theta, and finish with the dz. And my r would go 0 to the square root of 10, and my theta would go 0 to 2 pi. And then whatever the divergence is, can we just, for argument's sake, pretend in this new question, it was x plus y squared, right? Just for argument's sake, right? So pretend that was the divergence instead of 0. Do you see how we would set the limits of integration up based on this information? Now, all I would need to do next is convert these two guys into their polar form, right? So the x would become r cos theta, and the y squared would become r squared sine squared theta. And then you'd multiply by another r, so that would become that guy. And then you would do dr, d theta, and dz. And then theta goes 0 to 2 pi, r goes from 0 to root 10, and finish with z equals negative 3 to z equals 3. Are you all comfortable about how that question would then?
I just
Okay.
have one question.
Yes.
Should it be d theta, dr, dz?
Yes,
Because the
because
theta
of the
is-
order I went and put them in.
Yeah.
Correct. Yes. Now, imagine that wasn't negative 3 and 3. Could happen. It wouldn't change much, but it would change a little bit. Suppose it was z equals negative 1 to z equals 3. Right, if you go back to the original hyperboloid, finally got to say the thing properly, you get x squared plus y squared take away 1. So you will now get x squared plus y squared equals 2. Now, if you put this guy in, you get x squared plus y squared equals 10. Still with me? Z equals negative 1. Now, if you draw that one, don't you just get two circles? What would it look like? Theta would still go from 0 to 2 pi. Wouldn't the r go from the square root of 2 to square root of 10? So wouldn't it still work? Just a minor alteration to the result, right?